In this chapter, we're going to begin looking at technology, production, and cost for a firm. Our goal of this chapter is to try to understand a firm's decision-making process. For many of you, you'll be going into businesses or you'll be working for businesses, not analyzing individual choice. So this will more match your focus and be a lot more practical for you going forward in your career. So what is the point of a firm? What firms do, what function they serve, is to combine inputs to make the product to sell to customers. So these inputs can be workers, they can be machines, which we call capital, or they can be natural resources, like raw materials. And these produce the outputs, or the goods, that individuals purchase from firms. Now, economists have a slightly different definition of technology. So the way we're going to use technology in this chapter is technology is the process by which firms turn inputs into outputs of goods and services. This is much more broad than the everyday definition. This isn't just labor-saving machines, it's also new processes and new management techniques. So new technology doesn't have to be a physical, tangible object. So now any change in a firm's ability to turn its inputs and outputs, so any increase in productivity, we refer to this as a positive technological change. So let's look at an example of technological change. So an example from the textbook is UPS delivering packages. So in 2013, UPS was late delivering millions of Christmas packages. As Tom Hanks in Castaway would say, you might as well have been the post office. So to correct this in the following years, UPS could have hired more workers, or they could have purchased more capital like airplanes. Instead of doing either that, increasing those types of inputs, they decided to improve technology to make their workers more efficient. So they bought new scanners to help sorting to make it easier, more efficient. Better maps and routing for delivery drivers, so it took them less time to be out delivering packages. So they ended up trying to improve their technology by making the firm more productive. When we analyze firm behavior, we need to separate the time periods we're looking at in two time periods. I'm sure you can imagine what the short run and the long run mean, but let's go through some definitions that economists are going to use. So the short run, that's the period of time where at least one input is fixed. So, for instance, a firm might have a long-term lease on a factory that's too costly to get out of. So because that is fixed, however long that lease is going to be considered the short run. Even if that lease is set for the next 10, 15 years, 10, 15 years will be considered the short run for that firm because they cannot vary that one input. Now, in the long run, that's a period of time where firms can vary all of its inputs. So they can adapt new technology, they can increase or decrease the size of their plant, they can hire and fire workers. So how long is a long run? This varies from firm to firm. It's different based on each individual firm's different costs and different inputs that they're actually using. So just think of it as long enough period of time that anything can be changed for a firm. By splitting time up into two periods, that gives us different types of costs. First are variable costs. These are costs that change as output changes. So these are like wages, the cost of electricity, raw materials, shipping costs. As a firm produces more of a product, these variable costs will increase. On the other hand, firms also have fixed costs. These are costs that remain constant as output changes. So these include things like rental costs, insurance, advertising, things that they're not going to vary based off of changes in production in the short term. All costs can be classified as fixed cost or variable cost. So the total cost to a firm is going to equal the fixed cost plus the variable cost. Let's explore these types of costs for a soft drink company. So a beverage company turns its inputs, so things like intellectual property, labor, bottling and canning machines, sugar, factory, electricity. They turn these inputs into outputs, the beverages they actually sell. So as a beverage company increases the number of drinks of bottles, some of these inputs are going to stay the same, and some of them are going to rise. So in this case, the cost of labor is going to increase as the number of drinks increases. The sugar is going to increase as the number of drinks increase. And the electricity is going to increase as the number of drinks increase. But the intellectual property, the bottle and canning machines, the factory itself, the cost of those are going to remain the same no matter how many bottles of soda they create and bring to the market. So now remember we said that individuals face opportunity costs. Well, firms also face opportunity costs. They don't only face the cost of the money that they actually spend, but things that they could be spending money on, just like individuals. So explicit costs, these are costs that actually involve spending money. These are the tangible things that firms are spending their money on. The implicit cost is a non-monetary opportunity cost. It's important to remember that firms face both of these costs. So the explicit costs of running a firm are relatively easy for us to identify. Just look at what the firm spends money on. You can look at their balance sheet and see. The implicit costs are a little bit harder. Finding them involves identifying the resources used in a firm that could have been used for another beneficial purpose. So think, if you own your own company, you probably spend time working on the firm's activities. Even if you didn't, actually pay yourself explicitly for that time, it's still an opportunity cost. You could have been doing other things with that time. Now let's work through an example using a fictional pizza company. So let's suppose that Jill Johnson quits her job that earns her $30,000 a year, and she instead opens up a pizza store in Lorena. So she uses $50,000 from her own savings to buy equipment, so things like the furniture, the pizza ovens, that kind of stuff. And she also takes out a loan in order to begin this pizza shop. So now that her costs are listed above in the figure. The item in red are explicit costs. So there's things like the pizza dough, the tomato sauce, all the ingredients she's going to use, the wages she's going to pay her workers, the interest payments on the loan to buy the pizza ovens, the electricity she's going to use in the shop, and the actual lease for the store itself. These are all physical costs that she's actually paying for. Now the items in blue, these are the implicit costs. So things like her foregone salary, the interest on the money she could have earned, and economic depreciation, the decrease in the resale value of the capital items Jill bought. All of these implicit costs that we saw in the previous slide are real costs of Jill owning the pizza store, even though they don't require the explicit outlay of money. Even though she's not physically paying somebody, those implicit costs still exist, and they still impact her decision making. Implicit costs also include other jobs she could have taken or other businesses she could have run. So notice in particular, Jill charges herself for the money she took out of her savings, just like the bank would charge her for. Let's look at the production in Jill's pizza shop. So Jill's restaurant turns its inputs, so pizza oven, the ingredients for the pizza, labor, electricity, all these things into pizza for sale. So to make this analysis simple, let's only consider two inputs. Even though there's a lot more inputs, the more we include, the more we think about right now, the murkier things are going to get. So if we use two, it'll be very simple. So we'll look at pizza ovens and workers. The pizza ovens will be a fixed cost. We assume that Jill cannot change in the short run the number of ovens she has. Obviously, she can go out and buy another oven, but we're going to say because of the high cost for her just opening up her shop, she's stuck with what she has for the time being. Now, workers are going to be a variable cost, so we will assume that Jill can easily change the number of workers that she hires, that it's easy enough for her to go out and get another worker, that she can change these in the short run. So here we have a table with the short run production and the costs at Jill Johnson's restaurant. As you can see, the number of workers can vary from 0 to 6. For the quantity of pizza ovens, these are not going to vary at all. So Jill Johnson's restaurant has a particular technology by which it transforms workers and pizza ovens into pizzas. And with more workers, Jill can produce more pizzas. So this is the firm's primary function in this case. There's a relationship between the inputs employed, so in this case the workers and the pizza ovens, and the maximum output from those inputs. As you can see, in the third column, the quantity of pizzas per week increases as Jill hires more workers. But the cost of the pizza ovens, these are going to stay the same. Meanwhile, the cost of the workers, because these are variable costs, they'll increase as she hires more workers. From there, we can find the total cost of pizzas per week and the cost per pizza, so the average total cost. And we'll explore these more in the next slide. Each pizza oven costs $400 per week, and each worker is going to cost $650 per week. Because she has 2 pizza ovens, that's $800 in fixed costs that her firm has. So no matter how many pizzas they produce, even if they produce none, it's going to cost them $800 per week. Then every time they add a new employee, it's going to cost an additional $650. So those variable costs are going to increase as they produce more pizzas. Just like how we used the supply and demand schedule in order to create the supply and demand curves, we can use the total cost and the average total cost from the previous slide, from the table there, to graph the cost for Jill Johnson's restaurant. So on the right here, we have the total cost of producing pizzas per week for Jill Johnson's restaurant. I noticed that because we have a fixed cost, because we have those $800 worth of pizza ovens, the cost is not zero when the quantity is zero. Now naturally, as Jill wants to make more pizzas, she has to hire more workers, and it's going to increase the cost of her producing the pizzas. Now, if we divide the total cost of pizzas by the number of pizzas produced, we can get the average total cost of pizzas. So now for low levels of production, the average cost falls as the number of pizzas rises. But then at higher levels, the average cost is going to rise as the number of pizzas rises. Early on, it will be easy to produce more pizzas and to do so cheaply, so the average cost for pizza is going to fall. But over time, especially because in this case, the pizza ovens are fixed, that quantity is fixed in the short run, it will become more and more costly. Each individual worker is going to be producing fewer pizzas, so now the average total cost is going to begin increasing again once you pass a certain number of workers. Because the average total cost falls initially and then rises as the number of workers then begins to increase, this results in the U-shaped average total cost curve. So our next task, we're going to begin examining why we get this shape for the average total cost curve, why we see this U-shaped average total cost curve. So now let's think through of how Jill's pizza shop is going to create pizzas with the number of employees they have, how they're going to transform these inputs into pizzas. So suppose Jill hires just one worker. That worker has to take orders, they have to make and cook the pizzas, take the pizzas to the table, run the cash register, and you basically do everything there. So by hiring one additional worker, these tasks can be divided up, allowing for some specialization to take place, resulting from the division of labor. So one can say take orders and take the pizzas to the table. The other can make and cook the pizzas and run the cash register. And because they're just focusing on a smaller subset of responsibilities, over time they become more productive at those because they're doing the one thing over and over again. Now, 2 workers can probably produce more output per worker than 1 worker alone can do because they have this other person helping them out and they're becoming more skilled at their individual tasks as they're dividing it up. Now let's look what happens when Jill hires even more workers. So to think about this, consider the marginal product. Marginal product of labor is the additional output from hiring an additional worker. Remember, marginal equals the next unit. So in this case, it's the additional production being caused by an additional worker being hired. So when Jill moves from 0 workers to 1 worker, we go from 0 pizzas to 200 pizzas. So that first worker has a marginal product of labor of 200. They're now able to produce 200 more than they were before because of this additional worker. Moving from 1 workers to 2 workers, the number of pizzas being produced increases from 200 to 450. So the marginal product of labor, the difference between 1 worker and 2 workers, is 250. So the second worker has an even greater marginal product of labor. But now if we move from 2 workers to 3 workers, the quantity of pizzas being produced will increase from 450 to 550. Because it's only increasing by 100, the marginal product of labor of that third worker is only 100 pizzas. And you can see as we go on from 4 to 5 to 6, the marginal product of labor is going to continue to decrease. We see as we hire more and more workers, they're not increasing the potential output by as much as the initial early on workers. Eventually, you start getting in each other's way. There's only so many pizza ovens there, so you can only cook so many pizzas at the same time. There's only so many cash registers, only so many things to do. So once you get enough workers to actually run everything, you're going to see them producing less and less because of these additional workers that are coming. diminishing returns. At some point, adding more of a variable input, it could be labor, it could be anything else, any other variable input, to the same amount of a fixed input. So think of capital like the pizza oven, will cause the marginal product of that variable input to decline. So in this case, as we add more and more laborers with the same amount of pizza ovens, the marginal product of labor is going to decline. That's not just true for workers in the pizza industry, that's true for any firm. We graph the output against and the marginal product against the number of workers, we can see the law of diminishing returns more clearly. We can see it actually happen. So at first, the top figure, the more workers are hired, the increase in output grows. At first, sharply, and then the growth slows down as it goes on. So the marginal product of labor is decreasing, but it's still positive. So total output is going to increase just at a slower rate than it was initially, which you can capture pretty well, you can imagine pretty well from the first figure. Now the second figure graphs the marginal product. So we're seeing the marginal product of labor. You can see the initial increase from 1 to 2 workers, and then you see it dropping as we add additional workers. So you can actually see the marginal product of labor getting smaller. Another way to look at output is finding the average product of labor. Looking at total output divided by the number of workers. So if we have 3 workers producing 550 pieces, the average product of labor is going to be 550 divided by 3. So that equals 183.3. Marginal product of labor. So if worker 1 produces 200, worker 2 produces 250, and worker 3 produces 100, add those up and divide that number by 3. And again, you're going to get 183.3. So we look at the average product of labor for 2 workers in this case, you can see it's 225. It's 200 plus 250 divided by 2, 225. It's greater than 183.3. So when we have 2 workers, the average product of labor is greater than average product of labor when we have 3 workers. So this is another way to illustrate the law of diminishing returns, because this third worker decreases the average product of labor. Again, with only 2 workers, the average product of labor was 225. So third worker is making that average go down. So, like I said, this is just another way that we can highlight the marginal product. You can see